He's going to find out. I thought maybe somebody would get that. All right. So number 3. I'm not in the rejection region. So what's my quick little statement I can make?
Fail to reject.
Good. Failed to reject. Oh. Fail to support the high. Which one is the claim in this case? This is the claim. I like it. So I'm going to use this language, not that language. So we have not. We failed. You can even say we have failed to find. We have not found sufficient evidence to reject, because we're going to use this language, reject the claim that what?
The mean is less than.
The mean is at most 110. Or however you want to say it, it's less than or equal to 110, that's fine. Because, see that, I mean, your conclusion just has to be about your claim. It makes sense. You make a claim, you probably at the end want to tell people what happened to your claim. And that's all this is. Alright, so anything about that one? Okay, so what about number 4? We're not in the rejection region, so what can I say? Failed to reject the hope. Failed to support the hope. Sorry. So then, which one was the claim in this case? The high is the claim, so I want to use language related to the high. I'm going to use that language. So we have not found, because we failed, we've not found sufficient evidence to support the claim that what? Yeah, that the percentage is less than 32%.
So when you have reject, or fail to reject, the opposite will be, not the opposite, but always be fail.
Yeah, if I fail, so let's say you two guys, you're HO and you're H1. If I fail to reject you, what you said, I can't support what you said. So if I can't say you're wrong, I can't say you're right. If you have opposing viewpoints, right?
Yeah.
So if I can't say you're wrong, I can't say you're right. But if I can say, yeah, it looks like you're wrong, so it looks like you're right. So if I reject the null, I support the high. If I fail to reject the null, I fail to support the high. They're the same situation, just spoken from the two different viewpoints. And why do we have that? Because your claim could be either one. I have to be able to come at it from either viewpoint that I need. Maybe. Alright, so what about this last dude here? We're in the rejection region, so what can I say? Yeah, reject. We made it into the rejection region, so we reject the null. Support the high. Which one is the claim? Good, this is the claim, not that one. So I use this language. So we have found sufficient evidence. So do what? Reject the claim. That what? That the mean is 1.5. So either you get far enough away and you can reject that the middle is here, or you don't get far enough away and you fail to reject that the middle is here. You can never prove that the middle is there. That's why we never support the null. We can't. We reject it or we fail to reject it. Maybe. Alright. So, let's do this. I kind of want to show you some examples of what's coming up. Because the better you understand chapter 9, and like I said, 9 breaks it down. 9.1 just focuses on the hypotheses. 9.2 focuses on the errors. 9.3, I can't even remember. It focuses on another little piece of it. Which distribution can you use? It depends on if you know which standard deviation you know, or is it an NPQ problem? You can only use a Z distribution, right? 9.3 focuses on that. 9.4 actually really talks more about the whole idea of if I do something that's so unlikely, if this being the middle, and I do something that's so unlikely given that that's the middle, then it must mean that's not the middle. That's the whole idea. So 9.4 really focuses on that. So believe it or not, if you've never tried this, read the textbook, that section especially, because it actually gives you some examples of what that means and why we look at it that way. Okay, maybe. You're all like, read a textbook? What the hell world are you living in, Jeff? Let's see, and the 9.5 is where they finally unleash you on full hypothesis problems. Both percentages and means. All right. Oh. Well, that's right. So let's do this. Let's try out the next level of stuff here. We'll try a couple problems out from chapter 10, and then we'll call it a day if there's no other questions. And the very first thing I want to say, let me see if I can get you guys to go with me. So, tell me this. If I'm going to test a drug, let's say I'm going to test how quickly a pain reliever relieves your headache from a stats class. You leave stats class, you're like, again, I've got a headache from this. I have found sufficient evidence that Jeff gives me a headache. Because I have one every day. And I develop a new drug. I develop a new, like Tylenol kind of thing, right? And if you take it, I say it cures your headache faster. How do I prove that? How do you test it? What do you do? We should be familiar enough with this enough to talk about it. If I'm the person, how would I set it up? I would get some people to volunteer, and I would do what with the big group of people I got? So I get a big group of people to volunteer.
Give some
Good. And what would be true about those groups?
one years.
All right, control group. What's true about the control group? They don't get anything. Those poor people, right? We're like, oh, really? You have a headache? Well, just sit there. All right? Maybe they would do like that. So we actually do make 3 groups, but let's do this. Let's say we don't have a control group. Let's just go straight to it, right? So normally you would have a control group that would get nothing. But I really just want to, let's keep it between 2, because between 3 things is going to be difficult. That's going to be later. It's what's called ANOVAs, and that's a bit later. So let's keep it between 2 groups. So one group I'm going to give what?
Your drug.
I'm going to give my drug, right? So one group they're given my new drug. And the other group,
Placebo.
I can give them placebo, I can give them the old drug, right? So the other group is going to, let's say we give them a placebo, because that's normally what happens. To see if it has an effect at all in the first place, right? So if it's no better at curing headaches than a placebo is, people should just not spend a lot of money, just get sugar pills and just, those don't cost a lot of money. Just take those, oh, I feel better, sugar, yay. All right. Cool, I like it. So this should feel familiar. This is sort of a modification of the normal thing. We're not ready for the full-blown thing, because we can only compare 2 things at a time so far. So now watch. The normal z-score formula only has room for 1 sample. Well, that's kind of sucks. Because how many samples do I actually have? I got 2 groups of people. So this is a sample of the people. The population here would be everybody who would get the new drug. And the population here would be everybody who gets a placebo. So I need a way to compare two samples, not just a sample versus some given, average. I think the average is $3.19, and then we compare them. So where'd that come from? I want to actually have two samples to compare. That's getting a little closer to real life. So here's what happens. Let's see if you guys are cool with this. So what happens is I have to have two samples, right? Because I've got two samples that I'm going to deal with. Okay. And to be honest, now let me see if I can't argue this and then argue it away a little bit. What do you think the null hypothesis is going to be? What am I, as the researcher who created this drug, what am I fighting against? What's the null going to be? That these are the same. I like it. So the null is going to be that the average time for both of these is the same, and I'm trying to fight against that. How are we doing so far? I'm trying to show that my drug actually has an effect different from just the sugar pill. All right, I like it. So what really happens here is, instead of just doing this, I really have something like this and then a whole other set. So I have these two mu's over here also. But let me ask you this. If my null is that those are the same, what's mu1 minus mu2 going to be? 0. So if my null hypothesis is that those are the same, which is what it almost always is. I'm trying to show that there is a difference. So the null must be that they're the same. Then that must mean that that's going to be 0. Now here's, let's tear this bottom apart a little bit. All right, so I can't just put two standard deviations down here, believe it or not, because the variance is kind of like what rules the day here. So let me see if you guys can remember this. That's good, Jeff. Let me switch purple out for purple. All right, so we got this set up here. Remind me what sigma sub x bar is. What's the formula for that? Beautiful, right? Now watch. Let me do some geeky little math weird shit here. And you guys tell me if this is true. Is that true? What's the square root of sigma squared? And what's the square root of n? Square root of n. So is that true? Of course it's true. True all day long. So here's why I did that. Now I can make room for two variances, right? So now this becomes not just sigma over n, it becomes sigma 1 squared over n1 plus sigma 2 squared over n2. Now I don't have sigmas there, but also I could just put an s there, right? If I don't know the standard deviation of these populations, I could just use the s's instead of the sigmas. Are you guys with me on that? Exactly the same as we did before. If I don't have sigma, what do I use? S. Yes, ma'am.
So the ones and the twos are the sigmas, those are just representing which one they belong
The
to.
population. So I had the volunteers and I had the control, not control, I had the new drug group. So we can call these the ones. And I had the sugar pill group, the placebo group. We can call those the twos. So I'm going to get an X bar 2 from there. I'm going to get an X bar 1 from there. I'm going to get probably an S1 and an S2. So I would use S and S here instead of sigma, right? They're interchangeable. If I put S's in, I'm going to have to use
A t-score.
T-scores. That's all. Ooh. I really want you guys to get used to that idea. You use the standard deviation you have. If it's S, you use T-scores with them. If it's sigma, you use Z-scores with them. That's the whole idea. I like it. So formulas don't really change. You just put the correct standard deviation in, right? So look how this makes sense. I want to see, I'm trying to find evidence that there is a difference between the two. So how do I find, and difference in math is difference, right? Is subtraction. So I'm trying to see, and in the statistics, how do I measure how big that difference is? Z-scores, right? Or T-scores, they do the same thing. So I want to see how far apart are they relative to the data. So I want to make Z-scores out of this difference. So please let that make sense. So old hypothesis test, we would say, I take a sample, how far is that from some middle that somebody told me? I want to see how far apart those are. If it gets far enough apart, then this can't be the middle. Here I'm trying to say, how far apart are my two samples? If they're far enough apart, they cannot be equal to each other. If they're not far enough apart, they could be equal to each other. Yes, ma'am.
So you're getting one z-score for the difference
I love
of
it.
the 2 points?
Exactly. And the z-score represents how far apart the two samples are. I still can draw my rejection region. They still got to give me alpha. It could be a 1 or a 2 tail test. Right? Everything else is the same. It's just that when I get to step 4, I use this big bad mamma jamma to calculate the z-star. Not this little tiny mamma jamma. Trying to bring back mamma jamma. Alright. So let's try a problem now. This should be exciting. Oh, and before I get too far, we're going to do, the book has degrees of freedom formula that looks remarkably disgusting. That's now almost never used. So if I do have to use t-scores, if I have s's instead of z's, degrees of freedom is going to be n1 plus n2 minus 2. Okay. Oh, yeah, I guess I should be careful there. You go ahead and put S's in there just to make me feel better. So I can do this. All right. Here we go. So we're going to try a problem. Let's say, this is something I used to do when I had 2 different stats classes, but I could do it in here too. Let's say that I should have actually counted those 2 back first. Let's say that the men in here have an average grade of 78.1 with a standard deviation of, what makes sense, Jeff? 13.42. Let's say the women have an average grade of 80.02 with a standard deviation of 15.09. All right, I'm going to let you write all that stuff down. So just to warn you guys, in the homework and on my tests, I won't necessarily give you all the analysis. I'll just give you a list of grades. So you're going to do what with that? Plug it into L1, do 1 bar stats, get X bar and S, right? So you got to remember that process of how to do that. So there are some problems in the homework that just give you lists of data. Right? So this is after I've crunched the numbers and spit this out at me. And let's say that there, I don't know how many. Let's say there's 20 men and 26 women. Okay. So, and let's say the claim I'm going to make is that the average grades for men and women are the same. In statistics class. So, just because I put them first, right? No bias or anything. Let's call the men X1, S1, and N1. And we'll call the women X bar 2, S2, and N2. So you got to pick one of them to be 1, and the other one you pick to be 2.
Does it matter what order they go in?
It totally doesn't matter. Totally does not matter. If your tail is here one way, it's going to be the other side the other way. And you'll see it's going to work out here in a second. In fact, in this example, it really doesn't matter, because how many tail tests am I using for this? Careful. Well, let's get there. So step 1. Barney's kind of started step 1. But what's the null and the alternate hypothesis here? Let's see if you guys, you got to be careful here. What am I actually... So these are samples of men and women. So there's a male population and there's a female population. So there is a mu1 and there is a mu2. And I think that they're equal. So I think mu1 equals mu2. So the immediate thing to notice is there's no numbers in the claims, which only makes sense. The only reason there was a number is because I was supposing that I already knew something about a population on the other hypothesis test, which sometimes is true. Let me not poo-poo it too much, because that's obviously, very often that could be true. But what happens most of the time with statistical analyses is I don't know shit about either one. So my claim is going to be, I think they're the same, I think one's bigger than the other one, so forth. So there's no numbers going to show up here, because I don't know anything about what the population stuff is. I don't know, I just got my samples. So what's the alternate?
And one does not equal.
Yeah, the means are not equal to each other. So how many tail tests will this be? Two tail tests. Because to be not equal to, you could be greater or less. So you're going to have tail on both sides, maybe. Alright, so there are some slight differences, but all 5 steps are still there. They're all the same steps. It's just how I answer them is going to be a little different based on if I have 2 populations or 1. My formula is a little different if I have 1 sample or 2 samples. Of course, the 2 sample formula has got to be bigger because it's got to have room to fit 2 samples worth of information in it. So that's why this thing is so big. And you know in our future is going to be p hat 1 minus p hat 2, blah, blah, blah. Right? Or 2 proportions between 2 samples. Alright. Oh crap. Oh, well, you guys wrote that down. And I know it. So what's step 2? I guess I just have to say this. Let's assume that, let me just say it up here. These are normally distributed, or else I'm in trouble. So step 2, so it's normal, check. But then do I use T or Z scores?
C? No, T.
Yeah, why T? Because I only know the sample standard deviation. They are being remarkably nice because I actually wrote the symbol down, right? So in general, you got to pay attention and say, where did that standard deviation come? If you calculate it yourself, you should know. Don't just, now I love it when students, when you put in the calculator, what does the calculator tell you? Do you remember? It gives you S and sigma, doesn't it? So I have students say, well, I use these courses because my calculator told me what sigma was. But why does the calculator do that? It doesn't know if you're putting a sample in or a population in. It says you're the human, you know what's going on, I'm going to give you both. You better pick the right one. So if I have a sample, if I give you a sample set of data, you better pick sigma, listen to me, you better pick S, not sigma, because it's a sample standard deviation, so you have to use T-scores. All right, maybe. So it's normal, check, sigma unknown, T-scores. So let's say, assess this rejection region using alpha equal to, let's say 0.01. So it's a 2-tail test, T-scores. What's my degrees of freedom for this weirdness? I have N1 and N2, but I just do that. So that's different than the book, so you want to make a big note of that. The book gives you this disgusting formula I'm not going to make you use. This is something that works just as well as the disgusting formula. So what's my degrees of freedom?
44.
Yeah, 26 and 20 is 46, minus 2, 44. So degrees of freedom is 44. Alpha is 0.01, and I've got a 2-tail test. So 2 tails, 0.01. Degrees of freedom is 44. So what are we going to use?
44.
Sure, we're close enough to that. We're good. We can use 2.69. I like it. You guys still with me? So nothing really different on that step except since we have 2 samples, my degrees of freedom formula has to have both of them in there too. So what's the T-score, what did I just say, 2.690? Yeah. So what's that look like visually?
Negative.
Good, so it's got a negative 2.690, positive 2.690. So how do I say this in words? If T star is
Greater or less.
Well, you have two different scores. No?
T star is less.
How do I get into this rejection region?
I think less than negative.
Less than negative 2.690. Or T star, how do I get in that one?
Greater.
Greater than positive 2.690. Don't try to cut corners here, or else it won't make any damn sense. They're two separate areas that I have to try to get into. So to get into the lower one, I got to be less than negative 2.690. To get into the upper one, I got to be more than positive 2.690. Then we can do what?
Reject the null.
Reject the null, support the high. If I get in there, if I get in here, I fail to do those two things because it's not far enough away from. And in this case, just to let you guys know, this would represent zero difference, right? So I'm trying to show that there is a difference between the two. Because remember, the whole thing here is I want to show that there is a difference between the two drugs, right? Is that the one? No, there's this. We're not drugs anymore. I don't know if you guys are performance enhancing or not, but I'm trying to show that there's a difference between the two grades. Maybe. All right, you guys look appropriately excited about this. So see, now we got step one here. That was easy enough. I'm going to take that out of the way. Step 4. So again, all the steps are the same. First step is what the hell are you trying to say? Second step is what can you use to talk about it? Third step is what's far enough away? Fourth step is how far away did you get? I've got all my data that I need right here. The formula again.
Are we using T star?
Yeah.
Oh yeah, but remember, they're the same. But sure. So now you just got to plug and chug. So it'll be 78.1 minus 80.02 divided by square root. People always either square too much or square too little or put the wrong n with the wrong s, you know. So just pay attention to your subscripts. S1 squared over n1 plus s2 squared over n2. Okay. So let me try to do this in the... Oh my god. Well, the computer is having technical issues, so let's see. I'll just pray for you. When you put this in the calculator, just put parentheses on the top, put parentheses there, and you'll be golden. Something like 0.5.
I got negative 0.45.
That's pretty good.
Okay.
All right, sorry. I'll just be a bit excited. So negative, well, I don't know. Let's see if other people get that same thing.
Yeah.
Negative 0.45?
Yeah.
Yeah, well.
46? Okay. Couldn't remember what the next one was. Good. Negative 0.46? Cool. I like it. So is that very far apart? Were those grades very far apart?
No.
They were only like half a standard deviation apart from each other. So is that evidence that the population means are different? No. The samples were not very far apart from each other, so it's not evidence. Did we make it into the rejection region?
No.
No, we barely made it far at all. We made it there. Right, then we got a flat tire. We didn't make it very far at all. So we did not make it into the rejection region, so even the end is the same. So what can we say here? What's the quick thing we can say? Did we make it? No.
Yes.
So what did we do? Fail to reject H naught which means we also fail to support H1. Now, which one was my claim, HO or H1? Yeah, my claim was that they're the same. That was HO is my claim, right? Mu1 equals mu2, that was my claim. So I'm going to use this language when I write the conclusion. So try to write the conclusion. This is the actual physical situation, so you should be able to say it in terms of what is physically going on. So how do you start that off? We have not found. Good. We have not found sufficient evidence to do what? Reject the claim that what?
The average grade
The men and women's average grades are the same. So you can't say you support it. We just couldn't disprove. We could not disprove that they're the same. All right, so you can argue that, all right, well, maybe that means they're actually the same. We haven't shown evidence that they're different. If I constructed confidence intervals for both of these, they would not, they would overlap, right? That would mean that they could be the same, right? So that's another way to look at what's this happening. All right. Well, that's pretty good. That's as far as I thought I could make it today. That's crazy. I think that's plenty. So we actually just got into section 10.1. So make sure you understand what just happened. So work in the corrections for that quiz you just got back on YouTube. If you didn't get the quiz back, let me know. We still have this with you? Break check?
Thursday, I have an appointment before. Do you want to come? Okay, I won't come. I think it's yeah. I want to go there. Yeah. After going to the no, this class, I want to see when the test is and I want to make a test. Yeah. I wish we had school, but I have two tests in the same day.
Oh, okay.
Our class and this one. And yeah. I don't know what I'm going to do. I don't know why.